All right, welcome to Earth Science. We're back. Thanks for sticking with me. That was on the last one you did. I just wanted to do this in two, just to make it a little shorter for each one. But again, go back, watch these over, make sure you get this stuff down. Nothing's memorization. It's really just practice using all these tables. That's what I'm aiming for here. Can we practice a little bit using all these tables? What physical property can be observed in this, and it tells us up here that we're looking at muscovite mica. So what can we tell really just from this picture? So this one's not necessarily a reference table question, but cleavage, hardness, magnetism, streak. So what can you see? Streak's where you have that white plate and you make the mark with the mineral to scratch it and powder it to see what color the powder is. There's no evidence of that here. Magnetism, no evidence of that here. Hardness, there's nothing to say that this is harder or softer than another mineral. So I'm saying those three are bad answers. Cleavage, can we see cleavage in this? Yeah, cleavage is that idea that a mineral that exhibits cleavage breaks in the same way every time. It breaks along predetermined planes on a molecular level, often flat parallel planes parallel to each other. This one is that flexible thin sheet-like cleavage. The sheet silicates, they call that group. All right, 24. The mineral anorthite. Now, anorthite is not one that's on this mineral list. So we're starting, they're going to ask us what is similar to this. White to gray in color, hardness is 6, cleaves in 2 directions, and is used in making glass and ceramics. So what mineral does that most sound like? So they didn't give us, I like to go from left to right on this, they didn't give us a luster. So right away we don't know if we're up here or down here. But I guess if we looked, since these are in order, around 6, we're going to start to see that those other things don't match up at all. Fracture, the colors are wrong. That's kind of not working from the get-go. Here, if I go in order from softest to hardest, my 6s were right around here. So I've already got it limited down to like this. Cleaves in 2 directions. Cleaves in 2 directions, cleaves in 2 directions. Is used in making glass and ceramics. Used in making glass and ceramics. So this is really going to come down to what, again, is initially not the best thing to look for, is color, because there's so many minerals that might be white to gray. But now that we've got all this other stuff, and I've got it down to 2 minerals, the one is white to gray, one is white to pink, all the other stuff is the same. This is going to give me really my answer. If I come over here, should be the plagioclase feldspar. There you go. Those other ones are going to be off pretty good anyway. So if you were even in the neighborhood, that should have gotten you there, just by being patient and using the reference tables. Sorry if I'm being repetitive, but that is going to be how you get through this thing. What is the texture of inorganic, land-derived sedimentary rocks? That's an interesting question. And again, geez, I've been doing my work. Look at all these vocab words. It's got to be sitting on here somewhere. All right, so if I'm land-derived, I guess maybe that's where the meat of this question is. That's what might be where we get in trouble. Means that it's really made out of bits. So, hint, there's our answer. Clastic. Now, if you guess vesicular, you're fishing in the wrong creek. Vesicular lives on the igneous table, and that could be, again, a place where you're trying to fight. Geez, I can't figure it out, but at least I know this vesicular word is over here in igneous. And if this question's asking me sedimentary, I better not check that box. Okay, bioclastic and crystalline are both on here. That's good. And I'm not saying this is an easy question, but that's where we got chemicals for this precipitates and evaporates thing. If you remember the big beaker of salt we formed in the classroom that I showed you pictures of, or organically formed things, that's all living down here in the chemically and or organically formed half of the table. Inorganic, land-derived, there's that word hiding right there. Geez, it's plastic. Okay, so again, I'll stop repeating myself here, but use the table until you figure it out. I honestly, I missed that when I first looked through. Land-derived means plastic. And a difficult question becomes easy peasy. Which rock will weather at the fastest rates when exposed to acid rain? This one was, I would definitely not put this on your quiz, your online quiz, because we were not in class. We did not have the opportunity to run this experiment with acid. I threw it on here just to maybe bring this point up a little bit, but don't panic about this one. But bubbles with acid is calcite. This calcite, CaCO3, breaks down in acid. And I'll tell you where that is most common around here, if I can go to the right reference table, is that rocks that are made out of calcites, like limestone, will wear down. I think I showed you pictures way back at weathering, not that maybe you remember an individual picture from in class well over a month ago. But limestone having calcite in it, when acid rain hits it, it wears down the limestone. It eats away at it. This question really is just a fancy way of saying which of these has calcite in it. And if you went and looked at them all, quartzite has quartz in it. Gneiss has not calcite. And granite was our other choice. There's no calcium, no calcite in any igneous rocks. So limestone, and it actually buffers acid rain. So areas, if you've heard of acid rain as a problem, areas with lots of limestone, it ends up neutralizing the acidic rain. Areas that don't have much of that, here's where we'll talk. If you get into the harder rocks that don't have it, like the Adirondacks, acid rain is a bigger problem in the Adirondacks. There's not any limestone, there's not any sedimentary rock to neutralize the acid rain, so the acidity of water up there can build and build and build and build. Anyway, getting distracted. What map symbol is used to represent rock that formed as a result of the evaporation of seawater? Now, I haven't put one on there yet, but I'm not done making your quiz. So let's not forget, because I haven't really made a big deal of it, that on a map, these are the symbols that will be used. And there's questions where there's a diagram. They're out there. Again, I'm not sure I'm going to put one on your test, but there's questions where on a diagram it would just be rocks that have these symbols on it, and you would then have to go figure it out. So this one's reasonably straightforward. They just want to know which one of those forms is a result of evaporation of seawater. Take a minute until you find evaporation of seawater. So we're down to one of these guys. And it's looking like that's my one right there. Choice 2. Choice 3 looks like coal. Choice 1 looks like up here, breccia, made from bits of other rocks. What's that one with the humps? There we go, down here. There's a metamorphic rock phyllite. Evaporation, evaporite, you're good to go. Which 3 minerals are most likely going to be used in the construction of a house? So yeah, you're going to say, oh, how the heck do I know that? Which one have uses that might work for that? So do you need pencil lead and or lubricants to build a house? Not sure you do. Another choice within that one is ore of sulfur. So I'm not really liking number 1. Garnet, galena. I'm not really liking this one. Or galena, ore of lead, or batteries. So it's just kind of like, when we see it, it'll make sense. Talc, ceramics, and paper. Amphibole, mineral collections, and jewelry. I'm not sure I'm liking this one either. Down to choice 4. Let's see. Plaster Paris and drywall. You need that in a house. Dolomite, building stones. Can build a house out of that. Muscovite and mica. Paint and roofing. I like it. There you go. Patience, 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 and you got it. Photograph below shows a magnified view of a portion of rock that can float if placed in water. It's true. This rock can float. Some versions of it. So what best describes this rock? Those big holes like Swiss cheese. That's a vocab word you're going to want to know. Or don't know and just... Mine didn't print very well here, but it tells you vesicular is gas pocket. So if you just remember, hey, that gas pocket thing is over here somewhere. Gas pockets are vesicular. That probably should be close enough to get us our answer. Yeah, number 1, it's vesicular. Clastic and fragmental, no way. Those are sedimentary things. Foliate and banded, no way. Those are metamorphic things. Number 1 is our only good one. Which rock is never melted, but was produced by great heat and pressure, which distorted and rearranges minerals. So this is a really like fantastic version of just, can you through this recognize what kind of rock we're looking at? Never melted, heat and pressure, distorted and rearranges minerals. Heat and pressure makes metamorphic rock. Heat and pressure makes metamorphic rock. So we got to know which one of these is a metamorphic rock. And just take a minute, don't be hasty. Find them all. Siltstone. I'm sure you're capable of doing this, but siltstone lives in the sedimentary. Breccia lives in the sedimentary. Not it. Pegmatites. And I can do this fast because I've done it for years. You'll be a little slower, but you can do it. Lives on the igneous. That leaves us with only one choice. Hopefully it's right. Metaconglomerate. There it is. Lives on metamorphic. This question is just saying, give me a metamorphic rock. Do that and you got it. Last question was maybe slightly mean, because what it's going to make you do, it's going to make you go to a reference table I don't have up here because my review book's in the other room. If you go to pages 2 and 3, and again, I won't do this to you on your test. We want to know what's going on over here. Where are there possible oil fields and gas fields? The map shows the locations of some oil and gas fields in New York State. So if you went to that map and looked over there, it's basically just see which one you got. Is it igneous rock? Is it igneous rock? Is it metamorphic or is it sedimentary? If you remember that map of the bedrock, we have some metamorphic up here. We have a couple weird chunks of metamorphic over here, and pretty much the rest of the state is sedimentary. There's no mistake in this whole entire western half of New York State is all sedimentary rock. And maybe you could be clever enough to say, well, if you're getting these deposits of oil and gas, that has to come from life of somehow that was compacted. And part of this, that certainly doesn't come from like a volcano, right? So it'll be that. All right. Thanks for sticking with me on all this. Practice these things, guys. This is an easy test, potentially, if you're willing to take the time and go through all these reference tables. Thanks for sticking with me. We'll see you guys online soon. Good luck on the test. Welcome to Your Science.